Hello, this is SWATHIRAMYA, Assistant Professor, AIDS Department from SNS College of Engineering. You are here with me in NLP lecture series. In the previous video, we were discussing about the few components of ChatGPT, and in this session, we also going to discuss other few components of ChatGPT. In the previous session, we were discussing about the transformer architecture, which is the heart of the ChatGPT, which is very important component of the ChatGPT. It helps to analyze the concept, it helps to analyze the text that we give, and it will give you the relevant conceptual responses. Then we were discussing about self-attention mechanism. So it helps to find the dependencies of two words. That's a self-attention mechanism. Then we discussed about the tokenization. We know well about the tokenization. We will divide the word sentence into small, break the sentence into small words, or in some way we will divide the sentences into small parts. That is called tokenization. Next we go for positional encoding. So we have been divided the sentence into small words or small things. So we need the position of these words. So for that we are going for positional encoding. These four components we were discussing in previous video. In this video we are going to discuss about the other components of ChatGPT. Next, the fifth component will be FFNN, that is feed forward neural networks. Within each encoder and decoder layer of the transformer architecture, already we are discussed that in transformer architecture we will do encoding and decoding. So within each this encoder and decoder layer of the transformer architecture, this feed forward neural networks are applied to process the output of the self-attention mechanism. This FFNN consist of multiple layers of linear transformation followed by non-linear activation functions, such as it can be like rectified linear unit. Okay, so this FFNN enables the model to capture the complex pattern and relationship within the input data and facilitate the generation of conceptual rich representation. See, the main job of this FFNN is to capture the complex patterns in the relationship within the input data. That is, a relationship within the input data, and it helps to generate the rich responses, conceptual rich responses. That's the main work of FFNN. Okay. Next component will be the layer normalization and residual connection. See, the layer normalization and the residual connections are techniques used to stabilize and to improve the training of deep neural networks, including the transformer like ChatGPT. See, the main purpose of it is to stabilize and improve the training of the data. Okay, training of the algorithms. The layer normalization normalize the activation of each layer, help to migrate issues such as vanishing or exporting gradient during the training. Okay, it helps to normalize the activation of each layers. That is the main aim of this layer normalization. What is the use of residual connection? It is also known as a skip connection. It allows the model to retain the information from the earlier layer and facilitate the flow of gradients during the back propagation, so enabling the more stable and efficient training. It helps us to give you the more efficient training by allowing the by keeping the information of the previous layers. So that was the given in the name, that's residual connection. Okay, these are all the 6 layers. The 6 components of ChatGPT, which is most most needed, it is the main components of ChatGPT. But last but not least, that is output layer. At the output layer of the ChatGPT, a linear transformation followed by softmax activation function is typically applied to generate the probability distribution over the vocabulary of the possible tokens. During the interference, the model samples tokens from the probability distribution generated by the output layer to produce the next token in the sequence, iteratively generating the text until the supporting criteria is met. What the output layer is very simple. You have to, first of all, we are generating the output. See, for example, first token word has been displayed, so we need the next token. Okay, it will give you the probability distribution what the next word can be to this word. Okay, it is typically applied to generate. What we are doing is we are applying this and we are generating the probability distribution over the vocabulary of possible tokens. Okay, that is the main use of output layer. So with the help of understanding these components, we'll get the overview on how the ChatGPT has been working, how it has been working. Okay, next we will discuss about how the NLP has been involved in ChatGPT. Okay, that will be discussed in the next video. See you. Bye bye.